Okay, section 2.6. As I had said the other day, the next step is now to take all of those tools that we know about right angle triangles, put them all together and solve a right triangle. In solving a right triangle, we have to find all the missing angles and all the missing sides. So solving triangles. We have to find all sides and angles. Now, obviously, with some of the sides and angles, you'll be given them, such as this triangle here. We're given this side, KM, and we're given this side, MN. Now, you have to be given some sides, and you know what? We know we're dealing with a right angle triangle, so we're always given this angle as well. So there's only three other things that we have to solve for. And whatever tools you use to solve for that, well, unless it specifies, that's your choice. What are some of our choices as tools, though? We know that all triangles, the interior angles, add up to 180 degrees. That's one rule. We know that if it's a right triangle, we can use a squared plus b squared equals c squared. Pythagorean theorem. What's going on with my pen? Here we go. A squared plus b squared equals c squared. And that's a bad triangle too, so I'm going to fix that. There. Okay. So that's where we're at so far. Now, the last tool, obviously, we've been looking at right angle trig ratios, Sohcahtoa. Okay. We know that we can use that as well. Of course, that gives us the ratios of our three different trig ratios. Sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Now you choose of those three, if you need to use them, you choose which one you need, depending on the information you're given in your triangle. Now, if you're just told to solve a triangle, it doesn't matter which tools you use, just find all the missing sides and angles. If it specifically states, well, you solve this triangle using Pythagorean theorem and trig ratios, well then obviously you can't use the 180-degree rule. We want to see some calculations. So here's our triangle. Triangle KMN. We have two sides noted, and we have to find this missing angle K, whoops, this missing angle K, and this missing angle N, and this missing side here. Step 1. As per usual, step 1. Sohcahtoa. It's already written right there. I can leave it right there. Step 2, label our triangle. Well, we can't label our triangle without a reference angle, and I've got both angles kind of noted here, so I'm just going to erase one. I'm going to erase this one. And we're going to use angle K as our reference angle now. So if that's our reference angle, X is our hypotenuse, as always, opposite to the 90-degree angle, it's the longest side in the triangle. 11 would be our opposite side. And our last side, which is beside the angle we're talking about, is our adjacent side. Okay? So now we decide, okay, I'm going to solve for X. Or no, I don't need to solve for X right now. I'm going to solve for this angle K. If I'm solving for angle K, then what trig ratio relates opposite and adjacent? Tangent. Okay. Step 1, decide that. Write down our formula. Tangent of an angle is equal to opposite over adjacent. Substitute in our numbers. Tangent of an angle is equal to my opposite side, which was 11, and my adjacent side, which was 7. Just double check. Yep. Opposite side 11, adjacent side 7, and this was, this was angle K. Now, to find K, remember that if we're looking for an angle, or if you have this ugly decimal number, whatever this happens to be, 1 point something, you would have to use the inverse tangent button, or in this case the inverse tangent button. The inverse function finds the angle. So I find the tangent minus 1, or the inverse tangent of 11 over 7, which works out to 57.5288 something something something, or 58 degrees. So this angle now is 58 degrees. That's step 1. Step 2, now we need to find this other angle, angle N. At this point, there's 2 ways you can find this angle N. If you are super confident and you never make any mistakes, then you could say, well, if that is 58, then 180 minus 90 minus 58 is going to equal, what's it equal? 32. And say that angle N is 32 degrees. But what happens if you did this wrong? You did this wrong, then you got this wrong. You got 32 degrees wrong as well. Okay, so we're just going to quickly calculate that. In order to calculate that, though, I have to relabel my triangle. 7 now becomes my opposite side. 11 is my adjacent side. What is my ratio? Opposite and adjacent is tangent. Tangent of an angle is equal to opposite over adjacent. This time it's tangent of n, which is equal to my opposite side, which is 7 over 11. Remember, if I'm looking for an angle, I have to use the inverse function of, in this case, tangent. So tangent minus 1 of 7 over 11, which works out to, if I want some decimal numbers, 32.47119, or rounded to 32 degrees. So now we know that this angle N is 32 degrees. Now we just have to find x. Well, there's a whole number of different ways you can find x. You have the angle measurements. You could use cosine of an angle and find adjacent over hypotenuse and solve for x. You could use sine of an angle, find opposite over hypotenuse and find x. Either of those two would be fine. The best way, though, because you've done it so much and you used it in grade 8, well, not the best way, might be the easiest way for you, is if I have this triangle, which I do, this is 11, this is 7, and I want to find this, well, this is a right angle triangle where I'm trying to find the hypotenuse. I can simply use Pythagorean Theorem. Okay. So c squared is equal to 7 squared plus 11 squared, which is 49 plus 121, which is 170, he says questioningly. To find c, I take the square root of 170, which is equal to 13.03840481, or in this case 13.04, and my units centimeters. Equals 13.04. And that would be that question right there. Done and complete. Solve the triangle. I know all 3 sides. I know all 3 angles.